Check, check. Okay, good morning, everyone. Welcome to Dreamforce second day. I'm super happy to see people here so early in the morning. That means you care about security just as we do at Salesforce. So this is really, really great. We're going to talk today about the mobile SDK and focus specifically on security. My name is Martin Vigo. I'm a product security lead at Salesforce. I do work with different teams, including mobile, of course. I also do some authentication, identity. I work with field service, if you guys are familiar with it. So a lot of different stuff, always around security. So let's dive right in because we only have 20 minutes. So the first thing I wanted to do is to talk very briefly about the different types of mobile apps that there exist, because this is very important when we talk about the threat surface, right? In one hand, we have the fully native mobile apps, usually written in the operative system native programming language. The advantage is you have full access to the mobile device capabilities and functionalities like the GPS, like sensors, like access to pictures. On the other side of the spectrum, what we have is the web apps. And those are usually actually websites just with a wrapper around to make it look and feel like a mobile app. The advantage here is that you don't need a specific developers for every platform in the mobile ecosystem, but you don't have access to the sensors and some of the stuff. And in between, we find what is called the hybrid mobile apps, which is still apps written in CSS, HTML5, and JavaScript, but they have a JavaScript bridge to give you native access to the mobile device capabilities. So it's a nice sweet spot. Why do we talk about this? Because when we talk about the threats, we need to consider the entire landscape of the threat surface. On the left side, on your right side actually, what you have is a list of types of vulnerabilities that apply to mobile apps that are native. Things like issues with the file system and insecure storage. So that will be a lot of mobile apps today, they handle with sensitive data, right? So we need to store that securely. And so a lot of vulnerabilities go around that. Instead of storing it in the secure storage like the keychain or Android account manager, we just store it in the app sandbox, right? Especially on older devices, that's not a good idea. We have things around network communication. Do we protect how the client talks to the server? Can anyone at Starbucks just snoop into the traffic and tamper with it? We have things around crypto. The sensitive data that we have, if we don't store it in secure storage, how are we protecting it? Because we are types of files that just don't belong in the keychain, right? Like pictures, for example. Then we have RPCs like the clipboard. If I copy-paste something like a password, who can look into that? Who can sniff that? Backups. Backups is actually very interesting because as developers, from the moment one of our users does a backup, we lose control over that data. So what is the type of data that we allow to be backed up, right? Because some developers may not be aware that you can actually limit what the app allows to be backed up because not everyone encrypts the backups, right? And then things like URL schemes, there is attacks like the custom screen hijacking and things like that. Now, let's move to the web apps, right? Because we talk about the hybrid mobile apps. Now we have to take care about the types of vulnerabilities that apply to websites. Things like cross-site scripting, CSRF, like cross-site request forgery. SQL injection is one of the issues. And then all around like input validation or output encoding, we need to take that into account when we develop mobile apps, specifically that are hybrid or full web apps. So there's two things that we can do here. I can talk about the mobile SDK, how awesome it is, and focus on the things that interest me to say that the mobile SDK has, or I can take an independent third-party list from another organization that talks about what are the top 10 vulnerabilities and then run a checklist. And I think the second one is what will be fair. So OWASP is a non-profit organization that basically, among other things, what they do is they list every so often the top 10 vulnerabilities in different ecosystems. This one is the most recent one. It's from 2016, and it applies to the mobile apps. So these are the top 10 most common vulnerabilities that people find in mobile apps. So we're going to go one by one, explain them briefly, see what the consequences are, and then talk about how the mobile SDK helps you prevent it or helps you just not to commit those mistakes. Let's start. Top one. This is the most common vulnerability we find in mobile devices. So improper platform usage. What does this mean? We all, I'm sure you guys work with outstanding developers. But developers need to be experts in so many fields, in their programming language, in their technologies, in a full stack of crazy things and tools and programming languages. So they cannot be one man for everything. So not all of them have a full scope of understanding of security. So what we find is that the most common issues is that when developers write mobile apps, they don't have a full understanding of the security capabilities that the operative systems offers. And sometimes they just don't implement it, or when they implement it, they do it in the wrong way because they don't understand the documentation, or because it's simply very complex, like cryptography. So we found that sometimes even violation of conventions leads to vulnerabilities. So how does the mobile SDK help here? So first of all, and most important, the mobile SDK is open source. You can go right now and get access to the source code on GitHub. We have a specific security training. I actually do some of that training and some security champions program in which we actually teach our developers about secure coding. So they are not only fantastic developers, but they are secure coders. This is very, very important because the bugs that don't get to us are bugs that we don't have to deal with and won't make it to production. We have code reviews as part of the software development lifecycle, and we also have independent security reviews in different flavors, like, as I mentioned, in-house, but we pay third parties to have security checks and look at our apps. We have different scanners, and we actually have a private bug bounty in which we get the elite top hackers to look at our mobile apps, and we pay them if they found stuff. And they will hold us accountable, believe me, if we don't fix what they report. So the second one is insecure data storage, which we briefly mentioned before, right? And here we have, so there is two types of storage. There is the explicit storage and the storage that happens automatically that maybe developers may not be aware of. So in explicit storage is I'm coding an app, there is authentication, so I want to store the password, which I shouldn't because on the client side you should not do that, but I have to store a session token maybe, or like maybe some personal identifiable information, full names, maybe social security numbers, hopefully not. So that kind of data, we find it that is unprotected sitting on the app sandbox at rest, and there is techniques to extract that from mobile devices, especially if they are not PIN protected, right? Then we have, as I mentioned, automatic storage, things like temp files and cache data. Why are temp files an issue? Because if a temp file contains sensitive data, maybe developers think it's a temp file, it's going to go away. But if the app crashes, or the user just kills the app by swiping up, for example, the file will sit there. And if there is not a cleanup process in place, that file will stay there forever. So we have an issue. Leaks in logs, I mean, we need to log a lot while we are in development phase. And if we don't mask sensitive data when we go to production or completely remove the logging, which sometimes is not possible because you need to keep track to be able to solve bugs that may show up in production, we have an issue there because access to the logs is very simple. We have to take care of what we send to third parties. If you use things like Crashlytics or Logalytics, make sure that you don't have any sensitive data that now even leaves your control to a third party, right? That will be bad, especially in the GDPR world that we live in. And caches, we already talked about it, especially issues, unique URLs. Sometimes you can think of when you share a folder maybe online and you don't want people to have to authenticate to the service, so the security relies on the uniqueness on the URL, is usually with a long hash. So if we find that in the caches, then there is sensitive data there that shouldn't be there. So mobile SDK, we try not to leave any trace, and I don't want to, nothing is 100% secure, so I don't want to use a language that is, will leave no trace, right? But we try very hard. So it uses OS-provided secure storage for storing secrets. We encrypt all sensitive files. That means not just the OS-provided crypto layer, excuse me, I keep moving, but we add our own layer of security because there is a number of threats that we can prevent if we add an addition our own layer of security. We do not log any sensitive data, we just remove it for production, server-side and client-side cache controls, and we have cleanup routines in case some temp files are left behind. Insecure communication, this is all about network traffic. First of all, don't use HTTPS. That will be clear text network traffic. As I mentioned before, if you sit in a cafeteria, super simple to do a man in the middle and tamper with your traffic. So you have to use HTTPS. But we cannot stop there because HTTPS can still have some consequences. What version do you use? Do you use SSL3 that is vulnerable to many known attacks that have been presented and tools have been introduced for? What kind of cipher suits? Are you even enforcing HTTPS? Can someone do a downgrade attack? Or do you have mixed content in which you have some URLs that are HTTPS, some URLs that are HTTP, so your cookies will be leaking through those if you load your images over HTTP, for example. Certificates, we find a lot that while you are in development phase, certificates used to be expensive. Now, thanks to the EFF, you have things like Let's Encrypt, check it out. So while you are developing, you use all your own self-signed certificates, right? And sometimes you write code to bypass the checks of certificates. What happens is that sometimes developers forget to remove that, and now you have all that fancy encryption, but anyone can just issue a certificate that is self-signed because the app doesn't check it, and now you can tamper with the traffic again. And then we have to take into account other protocols like Bluetooth and NFC. I have to go a little faster. So the mobile SDK uses HTTPS only, and we enforce it. We deprecated all the vulnerable existing cipher suites like TLS 1.0, SSL version 3. And we only accept trusted certificates, of course. So 4, insecure authentication. Authentication deals with checking that I am who I claim I am. So what we find is a lot in APIs is that sometimes there is no authentication for certain endpoints. Hackers tend to look for those, right? And that may be dealing to retrieving sensitive data or doing sensitive actions. Or there is basically poor entropy in the session tokens. If you use, and this is an exaggerated example, your username as the session token, that will be really bad because anyone can guess that or brute force it, right? What we find, a technique that hackers use, and this we learn a lot from our bug bounty program, is that they tend to focus on the mobile APIs. The reason is the web is usually very exposed, so there may be strong developers with an understanding of security better than the developers for mobile. So they tend to look at the mobile APIs because sometimes, I don't have a statistic, but those have a lower security bar, so it's a great entry point. Remember, an attacker just needs one entry point. So they will go for the weakest link. Sometimes passwords are stored insecurely, or there is no revocation. Who has lost a mobile device here before? You guys are all liars. At least 50% has to have lost his mobile device. You need a way in which you can revoke your session in case someone gets a hold of your device. So mobile SDK, we use standard protocols, like in this case OAuth 2.0. We don't store any password, and the session tokens we store are stored in the OS-provided secure storage. We have token revocation, and we even have inactivity logout in case your device gets compromised or you lost it in this case. There is a limited window, a time window for the attacker to compromise your device, your session in this case, sorry. Insufficient cryptography. This is a great example on the right side. First of all, you should have crypto, right, for your sensitive data. But here on the right, you see how an image has been encrypted with military-grade, industry-recommended AES crypto. But it was implemented in a mode that is insecure for this purpose. Here, what you see is that every single pixel was encrypted with AES ECB. So all the white pixels, because it was encrypted with ECB, ECB has a pitfall rather than a property that all clear text results in the same ciphertext if you use the same crypto key. So the result is this. This is very bad. The image is encrypted, but you use the wrong crypto method for it. So there is other ways to mess up with crypto. You may have crypto, but you use the not secure crypto keys or the no initialization vectors. So there is a lot of ways to mess up. The mobile SDK uses AES CBC, so even if you use the same cipher clear text to the same ciphertext with the same key, because you have an initialization vector that is also random, it will result in different ciphertext. We use secure keys as recommended by the industry, 256, unique per installation, so we don't share the same crypto key. It's stored in secure storage provided by the OS, or we can even derive it from the pin, so we don't even have to store it by using recommended password key derivation functions. performance. And we even offer you Smart Store. This is a great tool because it gives you an encrypted database that you can use to store data securely without having to know anything about crypto. This is fantastic. Next, insecure authorization. We talked about authentication. So authorization is about checking that I can do what I'm trying to do. For example, imagine that I'm Facebook, I'm trying to check a picture, right? And that picture has an ID of 123. And it belongs to you. So now I log in, I have a valid session, and I put that ID in the URL, and I can see it because it was only checked server-side. This is obviously not true. Facebook has super strong security. But basically what happens is the server-side only checked that I have an active session, that I'm logged in, but not that I can access that picture, which is when authorization comes into place. So that is what insecure direct object reference is. And these are very, very common. Or user roles are just messed up and there is not a clear permission model. There is hidden endpoints sometimes that are not documented so you can access and just that you have an active session is checked. Or that the checks are client side. This is bad because with a proxy you just basically bypass it. So the mobile SDK has a clear use role permission model. That's what we have at Salesforce. We check on every single request, and we check based on the session ID, not on some additional parameters that are in the URL, like, oh, user equals admin, right? Because anyone can tamper with that. Again, we do the check server side. We actually use the public APIs that you can use as well and are publicly documented. And again, we have all types of security reviews. Poor code quality. So this it relates kind of to the top one that we talked about, that developers don't take full advantage or correctly implement the security capabilities of the operative system. But in this case, it's more a low-level type of vulnerabilities. We're talking about buffer overflows or format stream vulnerabilities. These are very uncommon, but the impact is big because it can turn into remote code execution, memory leaks, and all that kind of stuff. So it comes also from ignoring best practices. Don't use, certain functions in C and stuff like that. Again, the mobile SDK is open source. Anyone can go check that we don't do that. Specific security training, again, very important to train our developers in security. We have code reviews just to look for those, and all types of independent third-party security reviews. Code tampering. This is a very interesting one because this is about tampering with the binary, right? For example, hooking into functions or patching the binary or modifying the memory. In reality, these type of vulnerabilities apply more to video games. Turns out the hackers like free coins and extra lives and to see the full map in the, they like to cheat. So they mess with the client side because a lot of mobile apps, a lot of games have a lot of the logic on the client side only for performance reasons. That's not the case with the mobile SDK. We don't care if you tamper with it. Again, it's even open source. So you can do anything. We do everything server side, so there won't be no issue there, as I mentioned here in this slide. So we're almost at the end. Reverse engineering. I love this one because we don't care. So this is about, and some banking apps may use it, it's basically adding that extra layer of security. So you don't only secure your app, but you want to make it as difficult as possible for hackers to understand how your mobile how your mobile app works, right? And this is all about reversing, decompiling, decompressing, decrypting your binaries, and just start messing with it. Again, in reality, this is security by obscurity. And I'm talking about the industry recommendations. You don't want to have that. If you need to hide how your implementation works, it's because you probably have something there that shouldn't be there. Hard-coded secrets or hidden endpoints or whatever. So we don't do that. Again, our mobile SDK is open source. And last but not least, extraneous functionality. I was training this morning how to pronounce extraneous. And this is about all kinds of things that are left, like special things that we sometimes find, like hidden menus. For example, we find it's very common. You go to the About button in the mobile app and click 5 times, and suddenly a developer menu pops up because developers need to test sometimes on the actual binary. So they enter these, like specific menus there to be able to test easily. Or they have legit backdoors, and don't get scared by backdoors, but sometimes they leave an SSH port open or just a port open to the app to be able to test, and they forget to remove it in the production version. Debug flags, test code, sometimes we find sensitive information there, or URLs that allow URLs to staging environments. So, I mean, and when I mean like the security community that works on pen testing. So the mobile SDK, again, is open source. We have a rigorous deployment lifecycle, and we have independent third-party security reviews. And I have 2 seconds, so conclusions. The mobile SDK is super cool. It's open source. It's an active project, so any issues you can report and stuff, we will fix it ASAP. It provides security through crypto by default, protecting all your data. It provides easy authentication out of the box, uses platform-specific security mechanisms. We take full advantage of it. It constantly reviewed by security engineers, and it's in our scope of the bug bounty, which should assure you that a lot of eyes are into them. Thank you so much for attending. I hope you liked the talk. You got something out of it. We have some other very interesting talks in security. The security booth is over there. I don't have time for questions, but I'm going to be hanging out there in case you have some, or you can just grab me out here. Thank you very much. Enjoy Dreamforce.